Alright, so this is an example of where we can combine dynamics and kinematics. We have a 12 kilogram block at the base of the ramp, and it's given an initial push resulting in an initial velocity of 3 meters per second up the ramp. So before we can actually do this, we know that as this thing is going to travel up the ramp, it's going to eventually slow down to 0 and then slide back down. So we've technically already solved the dynamics component of this problem. We know that there's force of gravity. We know that it's going to have a y component and an x component. And there's going to be normal force. On this one, we're saying there's no friction. But if there was friction, you can solve this. We literally just did this in the previous example. So what we see is sum of the forces in the x direction is mass times acceleration in the x direction. And there's just that force of gravity. So because it's going up the ramp, I'm going to say up is positive, right? Up is going to be positive. In this case, Fgx is actually opposing that positive motion. So minus Fgx. So mass times acceleration is equal to negative mg. That's going to be sine 30 degrees. See the masses cancel out. Ax is equal to negative g sine 30. And we did this, and I think it was the first example. We have negative 4.905 meters per second squared. And it's not my final answer, so I'm going to hold on to those extra sig figs. So I know it's going to decelerate at 4.905 meters per second squared. Now we can use kinematics. We say, okay, if we think back, we have d, the displacement up the ramp. Don't know that. There's some final velocity, there's some initial velocity, there's some acceleration, and there's some time. So V final, it's going to eventually reach 0 meters per second. V initial, it's 3.00 meters per second up the ramp. Acceleration, negative 4.905 meters per second squared, and t is unknown. So now we just need to choose an equation that has V final, V initial, acceleration, time, or distance, I should say. So the equation, we look at the formula sheet, V squared is equal to V0 squared plus 2AD. So V final, that's 0. V initial, acceleration is negative 4.905. And displacement, that's what we're trying to solve for. So we get, rearrange this equation, move the 3 over, 3 squared is 9. Becomes negative 9 when we move it over, divide by 2, divide by 4.905. We find our displacement is equal to 0.917 meters. A really interesting thing when with this inclined plane problems is if we have an object that is sliding up the ramp. Before we looked at what's happening, we're saying, okay, object here, it's going to slide down the ramp. We say force of gravity is down, normal force is up, and force of friction is in this direction. However, if we push an object up, and if there was friction, we have force of gravity is down, normal force is up and to the left like so, but friction is going to oppose our motion. So if we gave this thing a shove to make this thing, give this thing some initial velocity up the ramp again, friction opposes the direction of motion. So we saw in the previous examples for this on the left, we say sum of the forces in the x direction. This thing, when it's going down, if v is down the ramp, is equal to Fgx minus the force of friction. However, on this other scenario, the sum of the forces in the x direction is equal to negative Fgx minus the force of friction. So when it's going up the ramp, both force of gravity and force of friction are working together to slow this thing down. When it's sliding down the ramp, they're opposing each other because force of gravity and the force of friction are in opposite directions.